field of electronics and communications. He began his career at CDOT and then went on to work with Tata, Cisco, Motorola, and then finally returned to Cisco, where he is now. He'd like to present to you Mr. Amit Phadnis.
Talk at this over. Okay. What I'll do is I'll start with a quick video. Before that, I want to introduce the topic a little bit, so we have some context about what you're going to see. Considering that we will have people from different departments and not necessarily electronics or computer science background, and maybe from different things have been over the last few years or decades. I'm going to focus more on what's happening in the world at this point in time. What are the opportunities, and how do we see the network evolving from a technology standpoint? What are the applications that we can run on this network going forward? All right. So that's the topic of the day. We have other sort of esteemed guests out here. Okay, and you'll sort of hear very interesting topics from them too. But let me get on with my topic now. So Siddharth, if you can play the video. Begin with, and if you guys and before that even telegraph, which was 170 years ago. I don't want you to go year by year here, but essentially if you really look at it, if you look at major inventions, the typical time period initially was about 50 to 75 years, and if you click on that, okay, you see that as you progress another 70 odd years to get to general purpose electronic computer. And then you see the shrinkage of time for the subsequent innovations. And if you look at it now, you think about it, it's not really that much time away, right? It's about 14 years back. And in India, in Bangalore at that time, I got my first cell phone, okay? And it was really like a break event at our house. Because till then, every call that we had to make, we had to approach the neighbor. And the neighbor was a really proud owner of that device, so we won't get the access every single time. Right? And what it shows is, things can change very, very rapidly from a technology perspective. Right? Just about 10 years back, most people in India did not carry a cell phone. Today we are in a situation where almost everybody carries a cell phone. Right? And maybe everybody is on LinkedIn too. There are many social networking sites that you will be a part of. You must be downloading videos, almost every day, right, from YouTube. But these things were unheard of even 10 years back or even 6-7 years back. Okay, the network, the way it was designed, it was really, especially the data network, it was designed for data, and most corporates were using it, for running applications, which was, from a technical standpoint, not the best thing to do at that time. And not many people believe in it, but today it is a reality, right? So you run actually voice over IP networks, and most of the corporates today get connected not on the GSM network that you have, where you connect to a cell phone, but they connect on IP network because it's free, right? So especially when you want to talk to your families or you want to talk to people who are not in the country, it's a very, very handy tool. In fact, the pace of innovation is only increasing. For those of you who are in the electronics or computer science world, you must have heard of something called a Moore's law. Have you heard of Moore's law? Many of you would have heard of Moore's law. Essentially, Moore's law says that the power of computing, okay, increases how many years?
18 months.
18 months. Every 18 months. Isn't it? Now, there are different definitions of Moore's law. Essentially, most of the mainframe computers about 10 years back. Okay, and these mainframe computers used to occupy almost the size of this room. Okay, and they were water cooled or air cooled, and I still remember that when I used to enter the computer science department in my college. How much is exabytes? how much is petabytes. But it's not just that it's important. If you really look at the time it has taken for us to get the traffic from 10 to the power 18, which is exabytes, to 10 to the power 21, which is zettabytes, it's probably 4 to 5 years. Okay. Now the difference between the exabyte and the even more tedious. Essentially, you write your program, you submit this deck of cards to the computer center, okay, and go back, next day morning, right? These are big numbers for them. These are very, very huge numbers compared to where we are at this point in time. Today, there are roughly 13 billion devices connected to the network, and that number will go to about 50 billion. And what they would be doing, there will be one laptop, maybe that time the laptop would be sort of obsolete, okay, most certainly. It is getting obsolete even today. People don't really want to buy laptops. They're buying, what are they buying? Technologies. So first mega trend is urbanization. There's nothing technical about it. You can go to Google and you can sort of say urbanization 2020 and you will see by 2020 there would be at least 10 connected devices every household, 5 connected devices for every user and 5 billion internet. But almost everybody would be sort of wherever there is a connection possible, I think it would be really big in GDP size. Now what you see there, you can see the number of countries which are going to be above $1 trillion economy, right? India will be $6.2 trillion. China at that time would be $38 trillion. Okay. US will still stay number 1. Okay. But very close to that would be China, and then India would be probably 3rd or 4th. But there are a number of countries, which in turn is going to fuel a huge amount of economic activity and opportunities for people. So essentially, this is another trend where new countries will sort of come up, grow very, very rapidly. That opens up different types of opportunities and gives opportunities for many countries to leapfrog on technology, which is very important. Okay? So countries which are developing now are not going to take the same route that countries developed over the last 20 years. Right? They're not going to go through the transition of something or telephone line to a cell phone to a personal computer to a laptop and then to a tablet. Most likely they're going to leapfrog directly to a tablet. Right? That's the point plan. And I think that's the type of opportunity that exists to this trend. IP stack meaning different protocol layers running together, making that connection happen. Okay? We have shrunk that IP stack to just 4 kilobytes of memory. Just to give you some perspective, most of your smartphones today have at least 1 gigabyte of memory. This is another example of what is possible. If you are in medical sort of science, okay, people are talking of sensors. Again, if you walk into a building, we have a good, nice telepresence unit. Okay, one of the biggest challenges India has at this point in time is the availability of doctors. So it doesn't matter. We have a telepresence unit that you can actually put anywhere in the world, but at least it's not going to be that anymore. Right? You get a very small ring maybe, right, or a very small device somewhere on your body, which can do. You experience that? You do, right? It happens to all of us. Right? It happens more often, and sort of will open up huge amount of opportunities. Technology is not difficult. That I tell you. There are enough people in this room who are doing electrical engineering and computer science and electronics. And these are small devices with a very simple processor in most cases and a good amount of memory and a very small footprint. And therefore technology itself not going to be a big challenge. The business models are going to be interesting. They will be challenging. Right? So I think there are many such possibilities. Click on the next slide. Right? I've just sort of listed out multiple industries in which these things are possible. Right? And you can see government, traffic, retail, healthcare, okay, manufacturing, education, industrial activity, financial sector, and so on. Many of them. And look at the number of devices in each of those sectors. About 3 years consecutively and found out that the average occupancy of the building on any given day, on a working day, okay, is not more than 70%. 70% of the building is occupied, 30% of the building is not occupied on any given day. And if you really think through it, I think it makes sense. 5 to 6% of the people are on leave, right? About 2 to 4% of the people may be traveling, okay? Or people are, sort of just doing different things, right? This is a full day occupancy, by the way, right? If you really look at the time that the person actually spends in his or her queue, that is less than 30% in a day. Because rest of the time you're in meeting rooms, you're having lunch, you will be ability to choose from where you are getting the power. That's not very relevant in India at this point in time, but in a country like US, it may be. Because you can say that power is generated low. I don't want it. It has a bad carbon rating. Okay? This power is more green and can turn out into a beautiful design. Okay? And at the same time can control the amount of light that gets into the building. Right? Or the amount of cooling that it will require. Okay?
Smart connected vehicles are the next generation of cars that deliver safer and pleasant driving experience. But there's a third aspect to it where car manufacturers want to know a lot about the car itself. They want to know how the car is performing, what are the brakes doing, what are the engine temperature like, and they can help troubleshoot a problem much faster.
Configures itself to support that type of an application. Right? So that's called a self-organizing approach, and there's a lot of work that's happening there. Various types of device and data topologies. So you have a large number of sensors spread in the world, let's say. You can put overlay technologies or overlay demographics on this. Right? For example, if this is smart grid critical fault data, where there is a short circuit, okay, and that information is being carried on the network, that will take a particular path on the network. If it is billing information, it will take a different path on the network, correct? Because the billing information can go on self-powered devices, but you don't want to put the critical fault information on self-powered devices because you don't know what the status of the batteries or devices in many cases, right? So it's an intelligent amount of data, right? Huge amount of data should not be generated. That data needs to get processed. It needs to get filtered. Some sense out of data with that data is to get converted into. You would have heard telepresence, right? The word telepresence, you can go to YouTube and take a look at it. It's a very high resolution video wherein you can avoid travel by seamlessly connecting people in different locations as if they're sitting across the table. Now last year, about 6 months back, we introduced a technology where not just a high resolution video image is being sent, but you can also transmit smell. Almost everything is possible. Okay? Maybe checking of bags can also be possible at some point in time. You can simulate touch, right? And something is possible, right? So cloud becomes the sort of center or the brain power of this entire phenomena called sensor networks, and the sensor business models around it. Next slide, Siddharth. I already said this, the role of the cloud is to guarantee you that irrespective of which field you are studying in, you will touch this cloud somewhere. Okay? Many of the things that you will be doing even in basic sciences will be actually computed on cloud. One good example of what's happening from a cloud-centric perspective is that a lot of companies are saying that, look, I don't want to buy applications and run an hourglass. Okay? I want the application to respond very, very quickly. And that's the type of technology that gets developed on the network, where the network can sense what's getting downloaded from the cloud and then organize itself in terms of quality of service so that the end user experience is protected. Okay? That's going to be a very important phenomenon. I think it's a single network. It is simple to organize, simple to manage and monitor. Okay? So that's why we say one network, one management. There has to be one policy for that network. You can't have multiple policy elements. What happens when there is a short circuit in a grid? Okay? People talk about network of policies because if there is a short circuit in a particular area, career span, you will deal with very, very unrelated technologies that try to connect them together from your right? That's the way the business is going to go on. If you are in transportation, tremendous in front of you. You are in a very good part of the world, which has a very favorable people demographics. Okay, the business here is going to grow much more rapidly compared to the other parts of the world, and therefore get excited and feel good about the fact that you were born at the time when you were born. Right? That's one credit that you can give to somebody else, right? If you were born 30 years back, maybe you wouldn't have had that. Yeah.
With these advances, it leaves us incredibly open to taking down a whole electrical system or whatever.
No, absolutely.
What do you? I know you don't want to have time to that's a whole new topic, but
no, but I think you are absolutely right. You know, I didn't sort of mention and concern and challenges at this point in time, as you rightly said, is security. Okay, because what if there is a malintent, right? In a security, in a smart grid, okay, it can actually jeopardize people's lives, right? Very easily. Okay. What if there is a flaw in a system which is really controlling a huge amount of population behavior? It can really cause a huge amount of issues, right? And therefore, security is a very, very big concern. In fact, in all of these fields, whether it is cloud computing, whether it is a big topic of research. I'll give a very quick example, right? We secure the networks today by encryption technologies, essentially. The problem is that encryption is very you don't have the luxury of being able to run a complete encryption stack on that device to secure the data. So there is a lot of work that is being done as to how do you group secure certain logical groups, okay? And how do you make sure that that security relationship between that group and the rest of the world is kept intact? But that's just a very specific part of it. The other big piece of this is policy, right? And the security policy becomes a very big play. You get deducted from your bank account. People wouldn't have agreed to it because people have felt, well, that's really open to theft, right? So essentially what happens is, as you deploy applications, before people start consuming the applications, the security parameters around it get addressed as we go along. My sense is that security is going to be a big concern, big area of research, and a lot of money and time is going to be spent on it. But I don't think it will stop, okay, the progress of what's going to happen from a technical standpoint.
Exist and they're being controlled by a future, generations. They're controlling our mind and they're creating the past through computer systems. Just think about it, and probably by what time will it be possible for us to control our past and do it?
Well, I don't have a good answer for you, to be frank with you, right? Because there is, by the way, there is a lot of research that is being. But look, these are, the way I look at this, at least, this is my personal view, is that, I think this is, at some level these are realities, because, if you go deep into quantum physics, and if you start looking at time and space, okay, you realize that you may be existing on this world, which people are going to see maybe 3 light years away, okay, and this light gets reflected and reaches on some other planet or galaxy. They will see what you're doing today 3 light years away, maybe, right? And therefore they are actually looking into the past.
मतलब कि आप टेक्नोलॉजी की एरिया में क्या करें, इन द डिफेंस सेक्टर?
Yeah. हिंदी में बोलोगे इंग्लिश में?
आप इंग्लिश में फॉरेनर्स को भी समझना चाहिए.
Okay, so actually look, any other field, the defense field also is tremendously increasing in its use of technology overall, right? And essentially, in terms of visibility, in terms of remote control, okay, the technology is already very widely deployed, right? I mean, in terms of being able to sort of control an aircraft today, and you have an astronaut here who will use sensor technology, very, right? Whether it is night vision, whether it is remote sensing, whether it is ability to control things in different areas, and there is work going on, right? Now, more than that, I can't really tell you as to what is happening in the India defense. I'm not an expert, by the way, anyway.
सर जैसे हमारे पास सब कुछ है, लेकिन ड्रोन्स के मामले में यूएस इज द मास्टर एंड वी आर इन ए लर्निंग फेज. तो हमारे पास सब कुछ है, दिमाग है, आईआईटीज.
No, let's not claim that we are probably way behind US in terms of use of technology in defense. Right? That's a reality. Okay. A lot of that is also philosophical debate as to what do you want to do as a country, what you don't want to do. Solve all about that too. With, not just about what is possible and what is not possible right now. Okay. So that's a bigger question. You should actually ask a defense expert, and I'll tell you that will be a very interesting conversation, because the perceptions about what we know and our perceptions about what's happening in defense and what may actually be happening may be slightly different.
Actually, वहाँ पे विंग कमांडर और ग्रुप कैप्टन के पास
Okay, I can't help you with that, but see whether you can get